Hello from the IIT Guwahati hardware security team. This is the hardware experimental setup we have at our end. This is the SASEBO board we have explained in a document. This is the current probe which captures the trigger signal. This is the power supply which is used to power up the SASEBO. This is a Xilinx programmable USB cable which is used to dump the bit files from the FPGA onto the FPGA, and this USB cable is used to receive the plain text from the PC. This is the oscilloscope. We have a Tektronix MDO 4000 series oscilloscope. We have set it up in order to capture the triggers, and we have a range to capture nearly about 31,000 triggers as of now. Now I'll move on to the interface which is used to supply the plain text to the AES code dumped on the SASEBO. So this is basically a C# code which generates this GUI which is used to send the plain text to the SASEBO. Now we will start the sending of plain texts to the board. As you can see, for a delay of 1 second, 1000 milliseconds, that is 1 second, we are sending 100 traces or 100 plain texts. We are expecting all the traces to be captured by the oscilloscope. Now let's see how the oscilloscope captures all the traces. So the traces are being captured live, as you can see. We can see a flickering in the AES trace as well as in the trigger, thereby showing that the traces observed are corresponding to each plain text coming in from the SASEBO G checker application. We can see CSV files being saved, which are nothing but the trace samples, and we can see the trigger being captured here in the single run stop. And with every incoming plain text, the counter repeat gets incremented by 1, 56, 57, 58 and so on. So all these trace samples are stored in the CSV file which are imported to MATLAB, and then the CPA attacks are performed on MATLAB. Thank you.